Okay, we're starting a new topic this lesson. We're looking at mechanics and we're looking back at some of the things that we did last year as well in this. So you might find that you need to do a little bit of revision. We're looking at terminal velocity. Pause the video, have a go at the starter questions, and then we will go through them. Okay, so question 1 asks what the equation is that links force, mass, and acceleration. The equation is force equals mass times acceleration. Question 2 asks what a resultant force is. A resultant force is defined as the sum of all the forces acting on an object. So what happens to an object if the resultant force on it is 0? If the resultant force acting on an object is 0, then it will keep moving in a state of constant motion. So that might be it stays at the same velocity, or it might mean that it stays stationary. The motion doesn't change though if there's no resultant force. So if there is a resultant force, the motion will change, which means we've got an acceleration, a deceleration, or a change of direction. Then the last question asks for an example of an equal and opposite force pair. So for example, the gravity of the Earth is pulling me down with a force of say 500 newtons. The equal and opposite force to that would be me pulling the Earth upwards with a force of 500 newtons. And again, that would be a force of gravity. It's always the same force, but it's in the opposite direction and it's the same size. Okay, and it's acting on the opposite object. Okay, so if you're looking at equal and opposite force pairs, you're looking at the forces on the two different objects. Okay, so moving on to terminal velocity. It's one of my favourite bits of the course. So we start by me throwing a student out of a helicopter. I'm going to call our student Ari, for example, today. So as soon as I push Ari out of the aeroplane or the helicopter, he's going to have a downward force acting on him. And the only force initially is going to be downwards. And that's going to cause him to accelerate downwards. As obviously, acceleration means an increase in velocity. So he's speeding up in the downwards direction. As he speeds up, that's going to increase the amount of air resistance acting on him. So speeds up, the air resistance increases. That then reduces the resultant force acting on him. So the overall force acting on him gets less. So after he's been in the air for a little while, we're looking at diagram B. We've got a force now upwards of 350 newtons that we didn't have because his speed has increased. So we've got less acceleration than we had initially. It's still a downwards acceleration though, because the resultant force is acting downwards. And we can work out what exactly the force acting on him is by working out the difference in these two numbers. So 833 minus 350 gives us 483 newtons. So the resultant force is 483 newtons downwards. That will mean he continues to accelerate downwards, so his speed continues to build up, and therefore the upwards force, the air resistance on him, will continue to increase. So by diagram C, he's still accelerating downwards, but he's accelerating at a much slower rate because his resultant force is going to be less. We've now got 833 minus 700, which is 133 newtons. So the force downwards, the resultant force is getting less and less. Until we get to diagram D. In diagram D, what's happened is that because he's accelerated so much, he's now got an equal air resistance force upwards to the gravitational force downwards. The resultant force on him is therefore going to be 0, which means that there's no acceleration taking place. We call that terminal velocity, okay? So he's at constant velocity, he's no longer accelerating, and that we call the terminal velocity. Now, if I haven't given him a parachute, it really will be terminal, because the thing that's going to stop him moving is hitting the ground. Maybe I've been nice. Maybe I've given him a parachute. If I've given him a parachute, opening the parachute will increase his air resistance because it gives him a greater surface area. So the increased air resistance will mean that there's now a resultant force upwards, which will cause him to decelerate and slow down. Okay, so let's have a look at this gap fill. Pause the video, have a go at copying it out and filling it in for yourself, and then I'll go through the answers. Okay, so as the objects get faster, the resistive forces acting on them get bigger. When the resistive forces are equal to the accelerating force, e.g. the gravity or engine force equals the air resistance, then the resultant force becomes zero. This means that there is no resultant force and therefore no acceleration, so the velocity must be constant, and we call this the terminal velocity. Okay, let's have a look at this motion on a graph. So we're going to have a look first of all at a velocity time graph for a skydiver. What I'd like you to do, copy the diagram into your books and write a note for what is happening at each of stages 1 to 5. Pause the video while you do that, and then I'll go through what you should have put. Okay, so step 1, we have a downwards acceleration because the resultant force is acting downwards. The downwards force is much greater than the upwards force. So in your point, you should put downwards force is much greater than the upwards force. Therefore, there is a large acceleration downwards. And you can see that by the steepness of the curve. At point 2, we've had an increase in air resistance because the speed has increased. So if the speed increases, the air resistance increases. That leads to a lower resultant force, so the acceleration is less. There's still a downward acceleration, but there's less acceleration, which is why the graph is less steep. That gets to point 3, and that's where we're about hitting our terminal velocity. So the air resistance eventually becomes equal to the downward force, the force of gravity. When that happens, the acceleration becomes 0, and that means that we hit our terminal velocity. Now, point 4 is just after our parachute has been opened. So our canopy is opened, parachute opens, we get a significant increase in the amount of air resistance. The weight of the person doesn't change when the parachute's opened, so the result of the air resistance increasing is that there is an upwards resultant force, and that leads to the person decelerating. It doesn't cause them to start moving upwards, they just slow down. So they've got a large deceleration at that point. That's why we've got this nice steep graph. And at point 5, because they've slowed down, the air resistance gets less again. So eventually what happens is they get balanced again, the air resistance and the weight are the same again, and we get to another terminal velocity. But you'll note that this terminal velocity is much, much slower than the original terminal velocity was, which means it's safe for the person to land at the second terminal velocity. Okay, if we have a look at this now on a distance time graph, you can see that we're starting off at the highest distance, so 0 is the ground. So you can see that they're constantly falling throughout. Okay, it starts off where there's quite a big curve on the graph. That means that they are accelerating. It's not steep, so that means that the speed is low, but it's curving a lot, which means it's accelerating. When it gets to the straight line part, that tells us that the velocity is constant. That's our terminal velocity bit. And then the bit where it turns the other way, that's showing a deceleration. So that's where the parachute opens, and it's quite a sudden deceleration. And then after that point, we get to another straight line bit. So that's our second terminal velocity. Now, terminal velocity, and the idea of terminal velocity doesn't just apply to things moving vertically and things falling. It also works for things travelling horizontally. So I'd like you to have a go applying what you've just learnt to answer the question, why do cars have a top speed? Pause the video, I will go through the key points in a minute. Okay, so what you should have got, cars have a maximum possible thrust from the engines. The engine can only go at a maximum, put out a maximum possible thrust. As the car accelerates, the air resistance acting on it increases. That reduces the resultant force on the car. If the force is less, there will be less acceleration. Eventually, the air resistance will be equal in size to the thrust, which means that the resultant force would be zero, so the acceleration would be zero, and the car reaches terminal velocity. Okay, so give yourself a tick for each of the points that you managed to get. Jot down any points you didn't manage to get. I've got a PEQ on Fronter for you to have a go at, and that's what I want you to submit for me this lesson. Okay, hope this all made sense. Email me if you have any problems.